Okay. I believe that we're recording. I rather be sure than later on. Not sure. Start recording. Okay, we got recording. Right. So before we went to our break, I asked when do we actually carry out process annealing. Okay. So we are going to do an example. Yeah. So example. So we know that the fracture strain of steel, for example, just an example. So we know that fracture strain of steel is about 0.2 or 20%. Okay, for example. Okay. So what if now, right? We have a material. What if now we have a material? So I'm going to draw the material geometry. So what if we have our initial geometry okay, so this is our initial is about 1 meter. Okay. And then we are the process that we're going to carry out, the process of stretch. This is the way you spell stretch. S-T-R-E-T-C-H. S-T-R-E-T. S-T-R-E-T. You're going to stretch the workpiece. Okay. And then the final length is 1.5 meters. Okay. So so our initial geometry is 1 meter. We stretch it. Okay. The final geometry is 1.5 meter. Okay. So if we were to find the strain is equal to 1.5 minus 1 divided by 1. So it's 0.5 or 50%. Okay. But we know, right, this material will fail at 20%. Okay. It will fail at 20%. Okay. So that is the thing. So how do we go about making, so we are stuck with this, okay? We are stuck with, for example, okay, we are stuck, okay, we bought 1 meter, we're stuck, okay? The material has to be stretched to 1.5 meters. Okay. So this piece of steel that we bought, the fracture strain is what? 20%. Okay, for example, 20% fracture strain, or even better by knowing or even better by knowing its strain at the ultimate strength, for example, is equal to 0.15. Okay. So we know the ultimate strength will occur at 0.15. It will fracture at 0.2. Okay. So how do we go about processing this piece of steel? Okay. So this is where we have to incorporate process annealing. Okay. So the process that we're carrying out is stretching. So in between the stretching, we carry out annealing. Okay. So I'm going to do maybe 2 cycles. Okay. So we know that the material, okay, the material will fracture. We know that the material will fracture at 0.2 strain. Okay. And the strain to ultimate strength is 0.15. Okay. So why I highlight the 0.15? This is because we are going to stretch it to 0.15. Yeah, where we see the ultimate strength. We are not going to, can someone tell me why we are not going to stretch this to 0.17? Can anyone tell me why? Anyone?
Will the material break if we stretch it?
No, the break is at 0.2.
Will it start necking?
Yeah, well done. So we reach here, okay? So this is 0.15. This is 0.2. When it start netting at this region, when it start netting, what happens? Anyone? What happens? So this is the strain hardening. What happened when it start to net? Anyone? Cross sectional area changes. Yes? Drastically. All right? So that's the problem. Okay, that's why we want to hit close to its ultimate strength. Okay? So so we are only going to stretch to 0.15. We're not going to stretch to 0.2. Okay? So we're going to incorporate in, I can't spell now, okay, incorporate process annealing. Right? We cannot stretch to 0.2 because it will break. However, our final strain, okay, is 0.5. So how about we do it? So stage 1. All right, we do stage 1. We are going to induce a plastic strain of 0.15. Okay. So plastic strain equal to change in length divided by length original. Okay. So this is 0.15. We want to find what's delta L. So delta 1 minus delta naught over delta naught. So this is 1 over 1. So L1 is equal to 1.15. So we're going to stretch this to 1.15. Okay. So now I'm going to come to the top here. Okay. I'm going to draw the workpiece material. I'm going to just erase the top. Can I erase this? Are you okay? Let me check. Is there any question? Did you say when you are stretching we use process annealing? Samuel. So the process is known as stretching, okay, and then we're going to carry out annealing, okay. That's why we call it process annealing. Samuel, does that make sense now? You got 0.15 from 0.2. Yeah, okay. So Steve asked, you got 0.15 from 0.2 minus 0.5. No, I got 0.15 is because we are only going to stretch this to 0.15 because there will be no drastic change in cross-sectional area. If I go to 0.17, we go to necking. Necking will change the cross-sectional area. Steve, does that make sense to you now? Or you're still confused? You got 0.15. No, I got 0.15 because of its strain at the ultimate strength. Okay, Steve? From experimental work by looking at the stress strain curve, Steve. Okay, by looking at the stress strain curve, right, we saw at 0.15 it reached the ultimate strength. Is that okay? Okay, that's good. Okay, right. So now I'm going to sketch for you the microstructure now. Okay, I'm going to sketch for you the microstructure. So originally is 1 meter. So it's more like round. Okay. Then we carried out stretching. Okay. So this is stage 1. Stretching. So we stretch to 1.15. Okay. So now the microstructure is distorted. Now I'm drawing 2D. This is a 3D effect. Okay, I'm drawing a 2D. So the microstructure is round because we induce a stretch. Right now the microstructure is oval, as you can see. And as I repeat again, this is a 3D that's also depth coming in. Okay. So after this, right? So this is stage 1. We stretch to 1.15. Okay. So after that, we get the material. Okay, I like to keep the 1 point. We get the material. We carry out process annealing. Okay. We bring it for. So I'll call this I'll call this stage 2. Process annealing. So after we've done process annealing, okay, we know that this distance from here to here is 1.15 meters. After we've been through process annealing, the microstructures go back to become round. Okay, so now the microstructure is round after process annealing. Then the next stage, which is stage 3, okay, stage 3. I'm going to erase here. I'm going to do stage 3 calculation now here. Okay. So stage 3, we are going for stretching again. So the calculation is still the same. Epsilon equal to delta L over, now will be L1, right? So now we know this is 0.15. Okay, so this is L3 minus L1 over L1. So L3, so we're going to find out. So minus by 1.15